A very good morning, my dear students. Today we will discuss about different types of sources and signal, which is lecture 3 of electric circuit theory, and day by day I will cover all the syllabus of electric circuit theory. So myself, Mr. Santanu Noskar, Assistant Professor of Electrical Department, GKCM JIS Group, and these are my mail IDs: santanu.uyt@gmail.com, santanu.noskar_gkcm@jisgroup.org, and this is my Facebook page, being Electrify with Santanu. You can get all the lecture in my Facebook page and as well as my YouTube channel. So let's start. So this is your syllabus of electric circuit theory for BTech third sem electrical engineering. So name of the course is electric circuit theories, course code PCEE 301, semester third, and this is the teaching scheme: 3 hours per week lecture, and tutorial is 1 hour per week, and practical is 2 hours per week. And this is the credit point of your subject 4+1, and this is the examination scheme. So these are the objective which I have discussed previous, and this introduction class: continuous and discrete, fixed and time varying, linear and nonlinear, lumped and distributed, passive and active network and system, I have discussed in my previous video. And also I have discussed about coupled circuit, and whole coupled circuit I covered in my previous lecture. And today we will discuss about independent and dependent source, step, ramp, impulse, sinusoidal, square, sawtooth signal. So let's start, and day by day I will cover all the syllabus: Laplace, Fourier series, Fourier transform, two-port network, filter circuit. So start. What is an independent dependent voltage and current source? The source which supplies the active power to the network is known as the electrical source. The electrical source is of two types, namely independent source and dependent source. The independent and dependent source means whether the voltage or current source either depending upon some other source or they are acting independently. Okay, so these are the types of source. So first is energy source, and there are two types of energy source: direct source, which is DC, and alternating source, which is AC. And direct source can be classified by independent voltage source and current source, and dependent voltage and current source. And dependent voltage and current source can be classified by voltage controlled voltage source, which is called VCVS, voltage controlled current source, which is called VCCS, current controlled voltage source, which is called CCVS, and current controlled current source, which is called CCCS. These things are very important for electric circuit theory and for all electrical engineers. So please concentrate on my video. So first I will discuss about all those things step by step. So first, energy source. So primary energy source take many forms, including nuclear energy, fossil energy like oil, coal and natural gas, and renewable energy sources like wind, solar, geothermal and hydropower. These primary sources are converted into electricity and secondary energy source, which flows through power lines and other transmission infrastructure to your home and business. Actually, there are two types of energy sources: direct source and alternating source. So go through my next slide. So direct source. The voltage and the current are the direct sources. The direct sources is further classified as independent voltage and current source and dependent voltage and current source. So let's start the main things. Independent voltage and current source. Independent sources are that which does not depend on any other quantity in the circuit. They are two terminals device and has a constant value, like the voltage across the two terminal remain constant irrespective of all circuit conditions. The strength of voltage or current is not changed by any variation in the connected network. The source is said to be either independent voltage or independent current source. In this, value of voltage or current is fixed and is not adjustable. Okay, so go through my next slide, which is dependent voltage and current source, which is called DVCS. The sources whose output voltage or current is not fixed but depends on the voltage or current in another part of the circuit is called dependent or controlled source. They are four terminal device. When the strength of voltage or current change in the source for any change in the connected network, they are called dependent source. The dependent source are represented by diamond shape. These are the diamond shape. The dependent source further categorized as voltage control voltage source, which is called VCVS, voltage control current source, which is called VCCS, and current control voltage source, which is called CCVS. And one thing I have missed, which is CCCS. Here I have mentioned CCCS. Okay, so one by one I will discuss about all those things. So first, voltage control voltage source, VCVS. So this is the circuit diagram of VCVS. Okay, so in voltage control voltage source VCVS, the voltage source is dependent on any element of the circuit. In this figure, the voltage across the source terminal VAB is dependent on the voltage across the terminal VCD. Okay, so VAB proportional to VCD, or we can write VAB equals to K VCD. Here K is constant. Now we will go through the VCCS. In the voltage control current source, which is called VCCS, the current of the source IAV depends on the voltage across the terminal CD, which is VCD as shown in the figure, where IAB proportional to VCD and IAB equals to, this is the efficiency signal VCD. This is a constant. This constant is also called transconductance, and its unit is mho. So Mho is the unit of transconductance. Now comes to the next slide, which is current controlled voltage source, which is called CCVS. In the current controlled voltage source of the network depends upon the current of the network as shown in the figure. So here VAB proportional to ICD, or VAB equals to RICD, where R is a constant. Now comes to my next slide, which is CCCS. Okay, so this is called current control current source. Actually these are very easy thing. If you understand perfectly, these all are very easy thing, and this is the basic of electric circuit theory. So current control current source. In the current control current source, the current source is dependent on the current of the branch, another branch as shown in the figure. So IAB proportional to ICD and IAB proportional to beta ICD, where beta is also a constant. So comes to my next slide, alternating source. So what is an alternating source? In the network application, there are other types of source also where voltage or current vary with time, sinusoidally or exponentially, etc., are termed as alternating source. So previous we discussed about all DC source. Now we will discuss about the alternating source. Okay, so these are all the source which I have discussed thoroughly, and next I will come to the signal. Now the thing, what is signal? So a signal is an electrical or electromagnetic current that is used for carrying data from one device or another network to another. In the key components behind virtually all are commutation, computing and networking. So these are the all signal: a time domain signal, frequency domain signal, and this is some square signal. So this is the signal. Next come to the different types of signal. So in our syllabus we will discuss about the step signal, ramp signal, impulse signal, sinusoidal signal, square signal, sawtooth signal. There are also many types of signal, but I will go through the syllabus. Okay. So at first, unit step signal. So unit step function is denoted by UT. It is defined as UT equals to 1 when t greater than equals to 0, and UT equals to 0 when t less than equals to 0. So it is used as base test signal. Area under unit step function is called UT. Okay. So next, unit impulse function. So impulse function is denoted by lambda t, and it is defined as lambda t equals to 1 when t equals to 0 and equals to 0 when t not equals to 0. Okay. So next come to the ramp signal. Ramp signal is denoted by RT, and it is defined as RT equals to t when t greater than equals to 0 and RT equals to 0 when t less than equals to 0. Next comes to the very important thing of relation between the standard signal. So if we derivative of step signal, then it comes to impulse signal, and if we derivative the ramp signal, then it comes to step signal. In other word, we can say integration of impulse signal equals to step signal, integration of step signal equals to ramp signal. So mathematically, derivative of this signal is impulse signal, and which I have discussed, integral of impulse signal is called step signal, and derivative of ramp signal is impulse signal, and integral of impulse signal is ramp signal. Okay, so now what is sine wave or sinusoidal wave signal? So sine wave or sinusoidal wave signal is special type of signal. It is given by the function ft equals to sine omega t or ft equals to a sine omega t plus phi, where omega equals to 2 phi f, and this is angular velocity and a is amplitude. Okay, now when sine wave starts from 0 and covers positive values, reach zeros, start from 0, cover positive values and reach zeros, it is said to have one cycle or single cycle. Okay, half cycle, you can also call half cycle. This upper part of sine wave is positive cycle, this is called positive cycle, and the lower part of the cycle is called negative cycle. Okay, so this is a single cycle. So this all to cover complete one cycle is called the time period, and frequency is 1 by time period, and also we can say time period is 1 by frequency. So from here we can calculate the frequency, calculate the time period, and we knows that what is cycle. Okay, so sinusoidal signal need not start at 0, it may start after certain duration of time. So look here, it can start from this, not only from 0, from here also, here also, here also. So it may start after certain duration of time. Okay, so this time after which sinusoidal signal start, it indicates with the help of the phase difference phi. Okay, so this phi is called phase difference. It is measured in radian. Okay, and this pole is the wavelength, and this is called amplitude. This. So next to the square signal. What is square signal? A square signal is a non-sinusoidal periodic waveform in which the amplitude alternates at a steady frequency between fixed minimum and maximum values with the same duration at minimum and maximum. Although not realizable in physical system, the transition between minimum and maximum is instantaneous for an ideal square wave. The square wave is a special case of a pulse wave which allows arbitrary duration at minimum and maximum. The ratio of the high period to the total period of a pulse wave is called duty cycle. A true square wave has a 50% duty cycle. Okay, now comes to the sawtooth signal. Sawtooth signal are another type of periodic waveform. As its name suggests, the shape of the waveform resembles as the teeth. So this is look like a teeth. Okay, of a saw blade. Sawtooth waveforms can have a mirror image of themselves by having either a slow rising but extremely steep decay, or extremely steep, almost vertical rise and slow decay as shown here. So this all my lecture, and now I will go some reference of my lecture. So this is the book, name is Circuit Theory and Network by S.P. Ghosh and A.K. Chakraborty. This book is very compact and good book for BTech and diploma engineers. So next book is Circuit and System by K.M. Soni. This is a old book but very good book according to my choice. This is a very good book also, which is called Circuit Theory, Analysis and Synthesis by Abhijit Chakraborty. Okay, now go through some site. NPTEL's video lecture by IIT, Electrical for You. This is very good site for electrical engineers, and Circuit Law. This is also a very good slide. So hope you all enjoy my lecture. So thank you. So next I will discuss about the electric network theory. So if you like my video, please share, comment and subscribe my channel. So thank you.